All right, so we've gone through, we've solved a bunch of linears, we've solved a bunch of quadratics, and now your teacher comes at you and says, so you big dude on campus, and says, you can solve quadratics, whoopty crap, can you unsolve them? So if I give you the solutions, can you give me the equation or an equation? Sure. Just work backwards. Ta-da! Alright, so here we go. I forgot my little tablet thing. Okay. So let's say, just for grins, they give you something like, I don't know, x equals -3 plus 2 roots of 5 and -3 minus 2 roots of 5, and they're like, okay, well, give me a quadratic. Give me an equation with these solutions. You're like, okay. Well, I mean, we kind of have to revisit on how we got the solutions. And so if we just take a really simple version here, we can see something like we got to a point and we're like, hey, this is like x plus 2 quantity squared is equal to 5. So we got to this point. And then we took the square root of things. And so 1, we took the square root. All right. And that gave us x plus 2 is equal to plus or minus the square root of 5. And then 2. We subtracted 2 from both sides. So we subtract 2. We subtract 2 from both sides. Gives us x is equal to -2 plus or minus root of 5. And then step 3. We just kind of separated these out and said, well, x is equal to -2 plus the root of 5, and x is equal to -2 minus the root of 5. Okay, well, now that we've got that, just go backwards. That's it. The end. Ta-da! And so sometimes I'll put additional restrictions on, like give me integer coefficients. Like, all right, whatever. So here we go. Let's take this. So we have our two solutions. Our solutions are -3 plus 2 roots of 5 and -3 minus 2 roots of 5. And what we're going to do is we're going to pack these back in. So to start with, what I'm going to go ahead and do is I'm going to go ahead and undo this kind of rootish thing. I'm sorry, I'm going to start down here. I'm jumping ahead. My mind is already trying to work. It's like, no, you got to do this. No, shh. All right, so first thing I'm going to do is just kind of recombine this. We're just going to take x is equal to -3 plus or minus 2 roots of 5. All right, well, the last thing that we did was to subtract the 2 over, so apparently the last thing we moved was this guy right there. And I'm going to use blue and yellow again because Michigan apparently won against Loyola. Good job. Loyola, you kicked butt. You killed a lot of people coming here. So, we've got x is equal to -3 plus or minus. We're going to go ahead and add 3 to both sides. Then we're going to take this. We're going to take x plus 3 must have been equal to this plus or minus 2 roots of 5. Well, 2 roots of 5, we can actually bring this 2 back in. You can do this now, or you can do this later. It doesn't really matter, but you're going to do it. So, we just square both sides. We took the square root, right? Just took the square root, so we're going to square both sides. When we do this, no matter which one of these you square, the plus or the minus, I didn't include the signs. The plus or the minus, when it gets squared, it's both going to become positive, so this is going to become x plus 3 quantity squared is equal to, and this is going to give you a square here, which undoes the radical, which is 2 squared times the root of 5 squared, which is equal to 4 times 5, which is 20. So this is going to be equal to 20. And then you just expand this out. Again, a quick way of doing it is simply to square the front to get the front, square the back to get the back, and then multiply these two, 3x, and then double it for 6x. You take this sign to the middle. This last sign is always a positive, equals 20. And now, for whatever reason, if they say, well, it has to equal 0. Okay, well, I guess. No reason to get kind of angry about it. Just subtract 20 from both sides. Now we have x squared plus 6x minus 11 is equal to 0. And there you go. That's it. Ta-da! Well, I want a function. Okay. Whoops. Just replace the equals 0 with equals f of x. Ta-da! It's like, well, I want the vertex. Oh, well, we're not going to get into the vertex this time, but we'll get there eventually. But this is just simply the idea, is that you can just kind of work backwards. So you're given the answer, now what's the question? Play Jeopardy with math. Why not? Let's do that. So let's take a look at something that's a little bit different. And we know that from experience, complex answers always come in conjugates. So let's try another one. Let's say that y equaled negative I square root of, I don't know, let's say square root of 6. Sure, why not? And that y is equal to positive I roots of 6, because they always come in conjugates. Perfect. So again, we just kind of combine them. Y is equal to plus or minus I roots of 6. That's kind of the two answers that came together. Okay, well then we just go ahead, and there's nothing out here. There's a 0 here, so there's nothing to move. We don't have to move anything away. So we can kind of think of this as not even being there, and then we can just go ahead and square both sides. So we square the y, we square this, and now careful, because both of these get the same thing. So this is going to be y squared is equal to, and this is going to be I squared times the root of 6 squared, which is just negative 1, times 6, which is negative 6. This is y squared equals negative 6. And then if we add 6 to both sides, then we go ahead and we get y squared plus 6 equals 0. And then, of course, if they want it in function notation, then we just do this. Ta-da! Or if they're like, well, I want a different function. Okay, let's take a different function. Ta-da! It's different. It's got a g. But that's really it. You're just kind of recombining those two solutions that they give you, and then you just square both sides and just be careful. Remember, the last thing that you did, if we come up here and we kind of analyze the order in which we did things, we took the root, then we moved, then we separated. So when we go back and we kind of work it back together, we're going to put back together, we're going to move, and then we're going to square. Move first, then square. It'll make your job so much easier. If you square it before you move it, it will be bad. You will be sad. Things will not work right. It will just be awful. So take my advice. Move before you square. All right, that's really it. I mean, there's no secret to it. And again, if they want a function, just put a g of x or an f of x or an h of x, or if you really want to get crazy, put like p of x. It's a polynomial. Ooh. Anyway, that's really all I got. So good luck going backwards. It's kind of fun.